Hello everyone. Welcome back to my channel, where we dive into solving challenging problems on LeetCode. Today, we're going to tackle the number of zigzag arrays problem, which is classified as hard. Don't worry if you're new to dynamic programming or if you've struggled with similar problems in the past, because by the end of this video, you'll have a solid understanding of the solution. So, let's quickly go over what the problem is asking. We need to find the number of arrays of a given length, where each element is within a certain range, and the array follows a zigzag pattern. This means that each element must be either greater than or less than its adjacent elements. It's a bit like trying to create a roller coaster with a series of hills and valleys, where each hill and valley must be within a certain height range. Now, let's talk about the intuition behind the solution. The key insight here is to use dynamic programming to track the counts of valid arrays ending at each position with a certain orientation, either increasing or decreasing. Think of it like building a tower with blocks, where each block must be either higher or lower than the one before it. We need to keep track of how many towers we can build at each step, and what their orientations are. This will allow us to efficiently calculate the total number of valid arrays. To solve this problem, we'll start by initializing the base cases for the first two elements in the array. Then, we'll iterate through the rest of the array, calculating the number of valid arrays that can be formed by considering all possible values for the current element and checking if it can be appended to the previous valid arrays. We'll use a 2D table to store the counts of valid arrays at each position, where the first dimension represents the position and the second dimension represents the orientation. Now, let's dive into the C++ code. We start by defining a class solution with a method number of arrays that takes three parameters, n, l, and r, which represent the length of the array, the lower bound of the range, and the upper bound of the range, respectively. We define a 2D vector dp to store the counts of valid arrays, where dp I0 represents the count of valid arrays ending at position I with an increasing orientation, and dp I1 represents the count of valid arrays ending at position I with a decreasing orientation. We initialize the base cases for the first two elements, and then we iterate through the rest of the array, updating the dp table accordingly. For each position, we consider all possible values for the current element and check if it can be appended to the previous valid arrays. We use a modulo operation to avoid overflow and ensure that our counts are within a valid range. In terms of time complexity, this solution is O, n, r, l plus 1, where n is the length of the array and r, l plus 1 is the range of values for each element. This is because we have a nested loop structure, with one loop iterating over the array length and another loop iterating over the possible values. For each element, the space complexity is O, n, where n is the length of the array, because we need to store the counts of valid arrays at each position. And that's it for today's problem. I hope you now have a good understanding of how to solve the number of zigzag arrays problem using dynamic programming. If you found this explanation helpful, please like the video, subscribe, and comment your approach below. Thanks for watching, and I'll see you in the next video.